Turbochargers. Turbochargers are now used by almost all automobile and truck manufacturers. A turbocharger has the ability to easily increase the horsepower of an engine by 50% or more. For this reason, they're commonly used on small inline four-cylinder engines like the one powering this high-speed test vehicle. Besides performance cars, turbochargers are also found on large diesel engines, in over-the-road trucks, and heavy equipment. Turbochargers, as you will learn, can increase the horsepower under a load and still have little effect on fuel economy at operating speeds. Normal aspiration means the engine uses atmospheric pressure to cause airflow into its combustion chambers. At sea level, this would be 14.7 psi. A turbocharger is an exhaust-driven blower that produces higher than atmospheric pressure for forcing more air into the engine to increase combustion pressure and power. Basically, it uses spinning fan blades and the resulting centrifugal force to push air into the engine. The power to spin the turbocharger comes from the engine exhaust gases. The exhaust is routed into one side of the turbocharger to spin a turbine blade. Then a fan or impeller on the other side of the turbo blows compressed air into the engine. This exploded view shows the major parts of a turbocharger. The center housing holds the turbine and impeller fans that mount on the shaft. Two large housings surround the compressor and turbine wheels. A waste gate valve can be used to limit maximum turbo boost or pressure. The waste gate diaphragm is free to open a passage to relieve exhaust pressure and regulate boost. If we cut away the outer housing of a turbocharger, you can easily see how one is constructed. We have removed a section of the turbine housing on the left and the compressor or impeller housing on the right. This cutaway of the center housing shows the steel shaft that connects the turbine and compressor wheels. The shaft mounts on soft bearings or bushings fitted into the center housing. A nut secures one of the wheels to the turbo shaft. The impeller or compressor wheel is mounted on the intake manifold side of the turbo. The shaft sends power to and spins the impeller wheel to build turbo boost pressure on the air flowing into the engine's intake manifold. The turbine wheel on the other side of the housing is rotated by exhaust gas flow. The exhaust leaving the engine is directed over the turbine wheel by the turbo housing. The exhaust manifold ports, painted red, direct all of the engine's burn gases into the turbine housing. After the gases flow over the turbine, they're directed into the car's exhaust system. An exhaust flange on the turbocharger bolts to a manifold that directs the hot gases into the exhaust system header pipe. Small sealing rings on each side of the shaft keep motor oil from entering the housing. After oil is force-fed into the turbo bearings, oil drains into the bottom of the housing and into a tube going back into the engine oil pan. Since the turbocharger can operate at speeds above 100,000 RPM, it is critical that the bearings are lubricated properly. Engine oil pressure is directed into the small passages in the center housing. The oil then flows down and over the bearings to protect them. Since the engine oil pump constantly circulates fresh oil through the turbo system, the turbo shaft is free to float on a thin film of oil. This oil also reduces the part temperatures. This external view of the turbo shows the oil drain line going from the center housing down to the oil pan. An intercooler is an air-to-air or coolant-to-air heat exchanger that reduces the temperature of the air entering the engine. It is a radiator-like device usually mounted at the pressure outlet of the turbocharger. Outside air flows through the intercooler fins. This reduces the temperature of the air being forced into the engine. Since compressing the air generates heat, the intercooler is needed to recool the air so that it is denser and carries more power-giving oxygen into the combustion chambers. Various tubes, hoses, and flex couplings route the pressurized air into and out of the intercooler. This animation shows the basic action of a turbocharger and its wastegate. Note that the pressure entering the vacuum diaphragm controls whether the wastegate is open or closed. When boost pressure is high enough, the diaphragm pushes the wastegate open. This bypasses some of the exhaust gases away from the turbine wheel to reduce turbocharger RPM and reduce boost pressure. When boost pressure is low, the wastegate closes and all of the exhaust gases are routed over the turbine wheel to produce maximum boost pressure going into the intake manifold of the engine. By regulating boost pressure, the wastegate protects the engine from damage. The diaphragm is able to react to changes in boost pressure. Movement of the diaphragm moves a rod going to the gate or a flap on the engine housing or outlet. When the diaphragm flexes to react to excess boost, it moves the rod going to the gate lever. In this way, the gate can be opened with excessive boost or closed with low or no boost. Turbo problems usually show up when the engine lacks power, when there is excessive smoke at the exhaust, abnormal noises at the turbo, or if the turbocharger vibrates. To diagnose problems, connect a test gauge to the engine intake manifold. Run a long hose into the passenger compartment so you can view the gauge while driving the truck or car. Accelerate the vehicle under load and read the boost pressure. If boost is below specs, you'd need to isolate the problem to the wastegate or to the turbo. Overboost is often due to a stuck wastegate. To remove a turbocharger from the engine for service, simply remove any parts that are in the way or connected to the turbo. Generally, unbolt the exhaust pipe or connections before the turbo. Also remove the hoses at the outlet of the turbo. Using tubing wrenches, unscrew and remove the oil lines going to and away from the center housing. Then unbolt the turbocharger assembly from its mounting bracket or pad on the engine. Carefully lift the unit off the engine without dropping it. Take the turbo to your workbench for teardown. First, remove the two clamps that hold the compressor and turbo housings onto the center housing. Note the orientation of the clamps for easier reassembly. Scribe mark the three housings at the clamp heads for later realignment if needed. Carefully lift off the compressor housing. Lay it to the side and remove the other clamp so that you can remove the turbine housing. Light wraps may be needed to free the turbine housing because of rust. Now, mount the center housing in a vise. Carefully tighten the vise jaws down so they clamp onto the turbo shaft hex. So you won't bend the turbo shaft, use a T-handle to loosen and remove the compressor shaft nut. Once it's freed up, spin it off with your fingers. This will allow you to lift off the compressor wheel. If light prying is needed, be extremely careful not to nick or dent the wheel because this could throw it out of balance and render it useless. Now you can unbolt the inner compressor housing plate. With the bolts removed, tap on the plate lightly if stuck before wiggling and lifting it off the center housing. After removal, use your fingers to push out the sealing ring inside the center of this plate. Keep the sealing ring organized so it can be reinstalled in the same way in the plate during reassembly. Use your fingernails or snap ring pliers to remove the sealing ring from the sealing ring carrier. New sealing rings will be installed, but you will probably use the carrier over again. Now you can unbolt the thrust collar assembly from the center housing. 3 bolts often hold it in place. After spinning out the 3 small screws, slide off the collar assembly. Separate the parts and inspect them for wear. Next, remove the O-ring from the center housing. It will be replaced during the rebuild. Light taps with a hammer will free the center housing from the shaft. Slide the metal cover off the shaft without spilling the carbon onto your workbench. Use snap ring pliers to remove the old sealing rings from the grooves in the turbo shaft. Wear eye protection when removing these rings. They are made of spring steel and can fly out with surprising force. If you find major damage inside the turbo, you might want to install a new or factory rebuilt turbocharger. You must weigh the cost of new parts and labor against the complete turbo assembly. Remove the outer washer and bushing from the center housing. Then use snap ring pliers to remove the snap ring holding the next bearing in place. With the snap ring out, use your fingers to reach in and remove the next bearing and washer. Keep parts organized to aid reassembly. You will install new bearings, but might need to use the washers over again. Repeat this disassembly process on the next snap ring, washer, and bearing. Take your time, because the inner snap ring can be difficult to reach and remove. With everything disassembled, inspect the turbo parts more closely. Wipe off and check the turbo shaft. Inspect the shaft where it rides on its bearings. Mic them if in doubt. Check each blade on the compressor and turbine wheel for signs of wear or damage. One nick or bend in any of the blades will throw the turbo out of balance. Also inspect the compressor and turbine housing. Look for cracks and other damage. Inspect the exhaust flange for cracks and warpage. Use a wood block and sandpaper to smooth and clean up critical surfaces on the turbine housing. Sand just enough to remove any rust and polish the surface. Thoroughly sand inside the grooves in the turbine housing to remove rust, carbon, and other debris. If a piece of rust were to fall down into the turbine while it's operating, turbine failure can result. Also, sand off the exhaust flange so that you'll not have exhaust leaks upon installation. If used cautiously, you can also use a bead blaster to clean up non-moving parts. Never blast the turbo wheels and shaft or they could be ruined. The abrasive action of the blaster can remove minute amounts of metal, throwing the turbo out of balance. The unit will vibrate and destroy itself upon reinstallation. Also, do not submerge aluminum parts in caustic-type cleaning agents, or they could be ruined. After blasting and washing parts in solvent, blow them clean and dry with compressed air. Methodically blow out all bolt holes, oil passages, and any area that could hold debris. Begin reassembly by installing the first snap ring into its groove in the center housing. You'll have to carefully work the snap ring into place with your pliers. Then, fit the thrust washer into place against the installed snap ring. Push it into place with your fingers. Check that you have the correct new bearings. They should match up dimensionally with the old bearings. Generously lubricate the bearings with heavy motor oil. Wipe down both the inside and the outside surfaces, then push the new bearing into place in the center housing. Next, install the snap ring up against this bearing. Double check that you work each snap ring fully down into its groove. Install the next well-lubricated turbocharger bearing, then position the next washer against the bearing. Assemble a thrust collar by fitting the disc groove into the fingers on the bracket. Position the collar assembly on the side of the center housing. Start its bolts by hand to prevent cross-threading, then torque them to specifications. Fit the new O-ring seal into its groove. Make sure the seal is fully down into place all the way around the groove, then lubricate the collar assembly. Work the new sealing rings into their carrier grooves. Be careful not to overbend and break them. Rotate the rings so that their split ends are facing away from each other. Staggering their end gaps will help them work together to prevent oil leakage. Wipe motor oil on the rings and then work them into position on the large end plate. Push inward with your fingernails to compress the rings, and they should slide into place. Don't force them, or you could damage or break the sealing rings. After installing the sealing ring assembly, fit the end plate onto the center housing. Start its bolts by hand, then torque them to specifications. Taking the time to torque bolts is very important because of the vibration that can occur during engine operation. It's wise to always check the end gap of sealing rings. Slide the correct size feeler gauge down into the ring gap when it's installed. If the gap is too large or too small, something is wrong. Slide another sealing ring down over the turbocharger shaft, then use your fingers or snap ring pliers to carefully spread the ring and fit it into the groove in the shaft. Wipe motor oil onto the shaft and the sealing ring. If you fail to lubricate parts, the turbocharger can be damaged when first starting the engine. It can take a few seconds for oil pressure to reach the turbo. Slide the cup into place on the shaft. Now, you're ready to install the center housing assembly. Position it over the turbo shaft and slowly work it down into position. Carefully wiggle and push down lightly on the housing to work it over the shaft. Never try to force the center housing down, or you can damage the sealing rings, thrust washers, or bearings. Take your time to be sure you don't damage anything. Once the housing is fully installed, it should turn freely. Next, slide the compressor wheel down over the shaft. Start its nut by hand to prevent cross-threading, then use a torque wrench to tighten the nut to specifications. To check your turbocharger rebuild, you should use a dial indicator to measure axial and radial play. For axial play, position the indicator tip so that it contacts the end of the turbo shaft. The indicator rod must be parallel with the shaft. Zero the indicator, and then wiggle the center housing back and forth to check axial clearance, also termed end play. If not correct, thrust washer or other part replacement would be required. To measure radial play, position the indicator so that it contacts the side of the turbo shaft. Wiggle the shaft sideways in its housing while reading the indicator. If your measurements are not acceptable, check turbo shaft and bushing sizes. Finish assembly of the turbocharger by installing the turbine and compressor housings. Fit the clamp into place on the turbine housing, then carefully fit the center housing into place. Make sure you align the housings properly so that the turbo installs on the engine without interference. Repeat this on the compressor housing. Make sure the clamp is centered over the lips formed on the center housing and the compressor housing. Fit the screw and hand start the threads, then tighten the clamps moderately to avoid damage. Spin the turbo by hand to make sure it's not binding. It's now ready for installation on the engine.